Okay, now we are going to discuss reactions with sodium hydroxide and potassium hydroxide. What will happen when the sodium hydroxide or the potassium hydroxide is added? I will list down set of observation and we will determine what is the conclusion that we can come from that set of observation. Now for an example, if we concern when sodium hydroxide or potassium hydroxide is added, if the solution gives a white precipitate, that it turns yellow on heating, right? Now I have added sodium hydroxide or the potassium hydroxide. Now the solution gives white precipitate at the beginning. With the time it turns yellow on heating. So what is the identification of the cation there? If any solution that it has bismuth ions, if any solution that it has bismuth ions, right, if any solution that it has a bismuth ion, that they gives a white precipitate at the beginning and turns yellow on heating. So actually the white precipitate is what? The solution contains Bi3 plus ions. I means bismuth ion. The white precipitate is then, the white precipitate is BiOH 3 times bismuth hydroxide. That is what the white precipitate is, right? So I go to my next one. Now there are many reactions that they are reacting with the sodium hydroxide, so this list will be very long. My first one is anything that it gives a white precipitate and makes a yellow on heating, that it contains bismuth ions, right? The next one is that I have this some solution. To that solution I add a sodium hydroxide or potassium hydroxide. It gives white precipitate and it soon turns very soon it turns black brown color. That is because why it makes a white precipitate. White precipitate is given because it contains manganese ion Mn2 plus, right? So what is this white precipitate is? What is this white precipitate is? Actually the white precipitate is MnOH twice manganese hydroxide is there, that is which the white color one, right? And then how it turns black on soon. Now when I have the manganese hydroxide, which is white precipitate manganese hydroxide, is actually that is white color precipitate. That white precipitate with the oxygen, it turns Mn2O3 with water, so that is what turns black brown color. This one is black brown, right? That is what black brown color is, right? I go to the next one. When sodium hydroxide or potassium hydroxide is added to some solution, that solution gives brown precipitate. So what will be the students results? Then sodium hydroxide or potassium hydroxide is added, it gives a brown precipitate. That means there are Ag plus ions. What is my conclusion? There should be Ag plus ion, right? So what is that brown precipitate is actually that Ag plus ion first react with the OH minus ion in the sodium hydroxide. It makes very unstable product AgOH and it converts to silver oxide like this. Silver oxide is that brown color precipitate, right? Silver oxide is that brown color thing. So I go to my next one. Now when sodium hydroxide or potassium hydroxide is added to some solution, that it gives red brown precipitate, right? It gives red brown precipitate. That means it contains Fe 3 plus ions, right? Okay, what is the red brown precipitate is, actually red brown precipitate is FeOH 3 times, FeOH 3 times, right? The next one, in a case that when I add sodium hydroxide or potassium hydroxide, if it gives a pink precipitate, if the pink precipitate is formed, that should contains, if the pink precipitate is formed, that should contains cobalt ion, that should contains cobalt ion CO2 plus. What is the precipitate is, the precipitate is actually COOH twice, right? This is what the pink color precipitate produces. This is what the pink color precipitate produces. Okay, now we discuss when the sodium hydroxide or potassium hydroxide is added, it gives a white precipitate, and yellow on heating there should be bismuth ion. If the white precipitate is gives, it turns brown black soon, there should be Mn2 plus ions. Manganese hydroxide is white, right? If it gives a brown precipitate, there should be Ag plus ions, because AgOH is unstable, it quickly turns to siloxide. And if it gives a red brown precipitate, there should be Fe3 plus ions. Red brown precipitate is what? Ferric hydroxide. We call that is ferric hydroxide. That is the precipitate is. If it gives a pink precipitate, pink color precipitate is formed, that means cobalt ions there in the solution, cobalt hydroxide is the one. The next one is, if it gives a blue color precipitate, if the blue precipitate is formed and it turns black when heating, what is blue color precipitate is, that is Cu2 plus ions are present, that is why it turns blue color. Actually, what is that blue precipitate is, that it makes a blue precipitate with the addition of sodium hydroxide. So the blue precipitate is CuOH twice, right? Actually, this is sky blue precipitation. This is sky blue precipitation, and it turns black color. It turns black color when heating, because when we heat, it makes copper oxide. When the copper hydroxide is heated, it makes copper oxide. That is what the black color thing is, right? That is what the black color thing is, right? So now we have identified a set of cations, how they react with the sodium hydroxide, potassium hydroxide. I will go to another set of cations, how they react. That is again how they react with the sodium hydroxide or potassium hydroxide. Observation, you have to think what is the identification is. When sodium hydroxide or potassium hydroxide is added, if my observation is green precipitate, right, green precipitate is formed and it turns black when heating. If the green precipitate is formed and it turns black when heating, so that should be nickel hydroxide. That means there are Ni2 plus ions in the solution. There should be Ni2 plus ions in the solution, and that green precipitate is what? Actually, the green precipitate is nickel hydroxide. The green precipitate is nickel hydroxide. And what is that black color oxide is? That is nickel oxide. The black color oxide is nickel oxide. This is what black. This is what the black color thing, and this is what the green color thing, right? And this is what the green color thing. And if sodium hydroxide or potassium hydroxide is added, if it gives a dirty green precipitate, and the dirty green precipitate gradually turns brown color, that means there are Fe2 plus ions, available in that solution. That what is that dirty green precipitate is? Dirty green precipitate is ferrous hydroxide. That is the green one, right? That is the green one. And the green precipitate gradually turns brown. How it turns brown? That is FeOH twice, right? This FeOH twice, green precipitate is oxidized to FeOH twice. That is why it turns brown color, right? And this one is very, very important. There are larger number of cations that they first make white precipitate and dissolve with excess sodium hydroxide or potassium hydroxide. When the sodium hydroxide or potassium hydroxide is added, if it makes white precipitate at the beginning, and if it dissolve with excess sodium hydroxide or potassium hydroxide, definitely there is amphoteric hydroxide. What are the amphoteric hydroxide? That means there should be amphoteric cations: lead, aluminium, zinc, Sb3 plus, Sn2 plus, Sn4 plus. They are amphoteric, right? So now look at here. When sodium hydroxide or potassium hydroxide is added, white precipitate is formed and it dissolves with excess sodium hydroxide or KOH. Look at here, there should be amphoteric cation. Pb2 plus is amphoteric. You know the lead is amphoteric. It reacts with the sodium hydroxide, makes a white precipitate, right? That white precipitate reacted with excess sodium hydroxide, and it dissolves like this. This is white precipitate and dissolves to make Na2PbO2, right? And aluminium ion, which is again amphoteric hydroxide, aluminium also reacts with sodium hydroxide and makes a white precipitate of aluminium hydroxide. Aluminium hydroxide white precipitate, right, reacted with excess sodium hydroxide and dissolves like this, right? Zinc is another amphoteric metal ion that reacts with sodium hydroxide, makes a white precipitate, and that also dissolves with excess sodium hydroxide like this. Antimony, tin also dissolves like this. Sn2 plus reacts with sodium hydroxide, makes SnOH twice, which is a white precipitate. That white precipitate dissolves with excess sodium hydroxide like this. Sn4 plus also same, that it makes a white precipitate. That white precipitate dissolves with dissolves with excess sodium hydroxide to make this thing, right? So the next one, another set of cations there. Again the sodium hydroxide and potassium hydroxide is added to some solution. The solution gives a green precipitate, and the green precipitate dissolves to form green solution. If something gives a green precipitate with a sodium hydroxide, that means it contains Cr3 plus, right, and dissolves to form deep green solution. That what is that green precipitate is? Actually the green precipitate is CrOH 3 times, right? CrOH 3 times. That is what the green thing. That green precipitate dissolves with the excess sodium hydroxide, right, to make green solution like this. This is precipitate denoted by S, and this is solution denoted by aqueous, right. The next one, when sodium hydroxide or potassium hydroxide is added, if the solution release ammonia gas, right, then it may contains ammonium chloride, right. You know, ammonium salts normally release ammonia with the base. That ammonium chloride is there. I add sodium hydroxide. So what we add? Sodium hydroxide. So the product is, right, so what is the product is? The product is sodium chloride. So sodium chloride plus ammonia plus water. So like that. Then the next one, when the sodium hydroxide or potassium hydroxide reacted with some salt or some solution, that it release ammonia gas, that means definitely it contains ammonium ion, right, and change the color from orange to yellow, that it releases ammonia gas, that means it should contains NH4 plus, and it turns orange to yellow, that means it should contain Cr2O7 2 minus, right. So that means what is the compound is, combination of both of these, that means ammonium dichromate is the sample, Cr2O7. The next one, then when I add sodium hydroxide or potassium hydroxide, if the color of the solution turns from orange to yellow, that means here it releases ammonia and turns orange to yellow. Here only turns orange to yellow in the presence of sodium hydroxide or potassium hydroxide. So what will happen? That means it turns orange to yellow. You know, it turns orange to yellow because in that solution dichromate ions are there. Dichromate ions react with the OH minus, that means the base, which is sodium hydroxide, converts to chromate. So the dichromate is orange color, right, and this one is yellow color. So now this theory part is very important. This theory part is very important for the inorganic identifications, and basically it is very important for the essay questions in the section C and section B. So you know that we discuss many set of all the cations, how they behave with the sodium hydroxide and potassium hydroxide. So I will give the photos of, I will upload the photos of this chart I made now, so you can refer that better in home, right. So okay, then thank you very much.